Hello everyone. Welcome to Controllers Tech. A lot of you guys requested a video on the LVGL, so today we will see how to make it work. I am going to use a parallel display for today's tutorial, and if you remember I have already covered a video on these displays. I would advise that you first watch that video, and make sure your display works, as in this video I will focus only on the LVGL part. I will be using the same library here also, along with the LVGL of course. If you are using any SPI-based display, make sure you already have the working display drivers. This video does not shows how to make the display work, but rather it's about the LVGL integration on a working display. Also, one more important thing before I start the video, this library does not support the touch interface, as I have not implemented it yet. But I am planning to do it soon, and I will update the code on the GitHub itself. So let's start the video now. First of all, we need to download the library files, so search for the LVGL GitHub. Here download the entire project. Now extract the zip file, and also open the official website. On the website, go to the Developers section. Here you can see there is a guide for porting, so open it. Open the first step in it. Here is the extracted folder. We don't need everything in it, like demos is not needed, along with that Zephyr folder. I will keep it though, since I am not going to include them anyway. Rename this folder to LVGL. Let's keep that aside, open the Cube IDE and create a new project. I am using F446RE controller. Give some name to the project, and click Finish. First set up the clock. I am running the system at maximum possible clock. Here these are the files from the previous video, where we interfaced some parallel displays. User setting contains the definitions for the pins, and I am going to keep them same. If you want to use different pins, I would suggest you to watch the previous video, as I have explained it there. My advice would be that you keep the pins same as they are shown here. Here the RD pin is the input pin, and the rest are all the output pins. Let's set the PA0 as input, and change its name to RD. Similarly, define other pins as output, and name them as per the file. Now go to the GPIO, select all the pins, and change their maximum output speed to very high, or whatever you have maximum. That's it for the Cube MX configuration. Click Save to generate the project. So our project has been generated. Now we will add the LVGL. Open the project folder, and copy the LVGL into the root of the folder. We also need to add the display library files into the project. So copy the source files into the source directory, and header files into the include directory. Now go inside the LVGL, and copy this configuration template file. Paste it in the main project folder, and remove the template from the name. Now refresh the project, so that the new files can show up here. Open the LVGL configuration file, and change this 0 to 1. This will enable the configuration. This configuration file can be used to enable or disable the functions that you want in the library. For example, the color depth is set to 16 for the RGB 565 display, the one I am using. You can read about the configuration file here, and change the options accordingly. If your controller have less RAM and flash sizes, you need to disable a lot of options, so read about them and change them as per your requirement. I am leaving everything to default for now. Next we need to include the LVGL folder in the source path. Open the project properties, go to C++ General, Path and Symbols, Source Location. Click Add Folder, and select LVGL folder. Click Apply to save the changes. Let's build the code once. We have 32 warnings, but it's alright. Let's start writing the main file. First of all we need to include the LVGL related files. These two dots and a slash means that we are going up a level. Right now we are in the main file, so one of these means we will reach the core folder, and another will take us to the root of the project folder. Now in the root folder, we will go inside the LVGL, and then include the LVGL header file. Similarly we are also including the LV examples header file. You can change these based on your project structure. Also include the LCD LVGL header file. This file basically connects the display drivers to the LVGL library, which we will see in a while. Let's build the code once. Everything seems good, there are no errors so far. Let's see the LCD LVGL source file now. Here in this file we have the display frame buffer. Because of the less memory available in the microcontroller, I cannot create a buffer large enough to store all the pixels for the display. This is why I am going to flush one row at a time, and this frame buffer have a size equal to the width or height, whatever is bigger. Next important thing is the display init function. Before we see this, let's take a look at the guide again. Here are the steps given for the initialization of the LVGL. First we need to call the lvinit function, which we will do later in the main file itself. Then we have to initialize the drivers. Here we need to initialize the LV display driver, along with the LCD display driver also. Next we need to register the display and input drivers. Since there is no input driver for now, I am only registering the LV display driver. Finally the steps 4 and 5, we will see them later. This part you might remember from the TFT video. Here we will set some rotation to the display, and here we are intimating the LVGL that the display has been rotated. The rotation is a parameter of the function, so we will input it in the main file itself. The next function is the TFT flush function. This will basically set the pixels according to the data saved in the frame buffer. First it checks for the screen area, and if everything is alright, we go next. As I mentioned earlier, because of the low memory available, I am going to flush one row at a time. So for every one row, we store the column data into the frame buffer. I tried flushing a single pixel at a time, but as expected, the entire process was very slow. If you have enough memory, you can store all the data into the frame buffer itself. We can even use the DMA2D feature of the ST, which is available in some microcontrollers. I will put all these different methods on the GitHub soon, but for now, let's just go with flushing one row at a time. After saving the row data into the frame buffer, I am calling the function fillFrameBuffer. This function will set the pixels as per the data in the frame buffer. The implementation of this function is very simple. Actually, I took the function fillRectangle and modified it a little. So instead of flushing the entire rectangle, it flushes one row only. Once we have finished flushing all the rows, we will call the function LVDisplayFlushReady. Of course, the flushing is a bit more complicated than this, and it involves flush callback and other things, but this here is the simplest implementation. If you guys want another video of showing LVGL on a more sophisticated controller, like H-series MCU, which will show the use of DMA also, and how we can use the different ways of flushing the frame buffer to the display, let me know in the comments. Or if you have low memory available on the controller, go ahead with this one. Next we need to include a timer for the LVGL, and therefore we will make some modifications in the interrupt file. Here in the sysTick handler, call the function LVTickInc, and pass the value 1 to indicate 1 millisecond. This is it for the setup. Now let's write the main code. Inside the main function, call the LVInit function. Now initialize the display. I am setting the rotation to 3. Give some delay so that everything is initialized properly. Now for the demonstration purpose, I will use one of the examples provided in the library itself. Let's use the animated example. I am using this animation 2 example. Call it once in the main function. Now inside the while loop, call the function LVTaskHandler, and also use some small delay. Let's build it. Everything seems okay so far. Also check the RAM and flash usage. Using animated example takes more memory, of course. Let's run the project now. You can see the animation playing on the display. This example is provided by the LVGL by default, and it works perfectly. Now I will show one more thing, where I will print a counter on the display. We can look for the examples in the text area widget section. Let's try this one, simple text area. We don't need to add the button event handler. Copy this part, and we will modify this later. First we are creating the text area. Then setting the text area to display in one line only. This is the alignment of the text area. Let's change it to center. Remove the event callback. Delete this also, as we don't need this part. I am removing all the button-related code too. Let's check some other functions available for text area. Add text is used to add the text where the cursor is pointing. Set text can be used to set the text in the text area. It replaces everything and put the text from the beginning. Let's use this set text function. The object name is TA, and the text we want to display is Hello World. Uncomment this, and call the function we just created. Seems like this function is already defined in the examples. Let's rename this, and try again. Everything seems good so far, so flash the code to the board. You can see the LCD displaying the Hello World in a text box. Now I will implement the counter. Create a variable which can increment. Let's add another function to update the text on the display. We need to utilize the object, so the object must have been defined globally. Define one buffer which can hold the string format for the counter. Now we will use the sprintf to convert the number to the string, and store the string into the buffer we created. Increment the index variable. And finally use the setText function to set the text in the object. We will call this updateText function in the while loop, so that the new counter value can update on the display. Alright, let's build and flash the code to the board. You can see the counter is updating. So everything is working pretty fine. You can use other examples, test them, and modify them according to your requirement. I will try to update the touch interface to this library, and update the code on GitHub. Also let me know in the comments if you want to see the LVGL integration in more advanced controllers like H7 series, which can use DMA, or the entire frame buffer in one flush. This is it for the video. You can download the code from the link in the description. Keep an eye on the GitHub for the update regarding the touch interface. That's all for now. Keep watching, and have a nice day ahead.